welcome back to my YouTube channel, Gita Saraswati. Previously, we learned about sequence and series. Now, in this video, we will learn about mathematics logic. But before that, don't forget to like, comment, and subscribe. So, let's enjoy learning. Okay, in mathematics logic, we learn to determine the value of a statement, whether it is true or false. The statement itself is divided into two types, namely 1. Closed statement. Closed statements or closed sentences are statements that already have true or false values. Example, 5 is an even number. The sentence is false because the correct number is 5 is an odd number. 2. Open statement. An open statement or an open sentence is a statement whose truth value cannot be determined because of a change or variable. Examples of mathematics logic: Px is 3x plus 1 greater than 6, where x is an element of real number. When x equals 1, then P1 is 3 multiplied 1 plus 1 greater than 6 is false. When x equals 2, then P2 is 3 multiplied 2 plus 1 greater than 6 is true. Next, about negation of a statement. Negation is the inverse value of a statement. When a statement is true, then the negation is false. And when a statement is false, the negation is true. The negation of the P statement is denoted by tilde P, like this. Then, counter statement. A counter statement is a form of mathematics logic in the form of a statement that has a quantity. In a counter statement, generally there are the words all, every, some, there, and part. Words that are word all, every belong to universal counters, and words that are word part, some, exist belong to existential counters. The universal counters and the existential counters negate each other. Example, P is everyone is a scholar. This is universal counters. Negation of P. Some people are not scholars. Next, about compound statements, equivalent forms, and their negations. In mathematics logic, several statements can be formed into one statement using logical conjunction such as and, or, then, and if and only if. The combined statement is called a compound statement. In mathematics logic, this conjunction each have their own symbol and terms. You can see this table. I'm sorry because still in bahasa. Okay, the conjunction and the symbol is like this. The terms is conjunction. Next, or. The symbol like this. And the terms is disjunction. Next, then. The symbol is like this. The terms is implication. And the last, if and only if. The symbol is like this, and the terms is be implication. Okay, conjunction truth table. We can see this table, but I'm so sorry because this table is still in bahasa. From the table, it can be concluded that the nature of the conjunction is true if the two constituent statements of the compound statement are both true. Next, truth table of disjunction. You can see this table. From the table, it can be concluded that the nature of the disjunction is false if the two constituent statements of the compound statement are both false. That truth implication table. We can see this table. On the nature of this implication, P then Q. P is called the hypothesis and Q is the conclusion. In this implication, it will be false when the conclusion is false and the hypothesis is true. For the last, truth the implication table. You can see this table. In the B-implicative nature, the compound expression will be true if the two constituent statements are the same, both are true, or both are false. Next, about tautology and contradiction. Tautology is a compound statement that is always true for all the possibilities, and contradiction is the opposite. That is a compound statement that is false for all the possibilities that exist. Now about equivalent forms of compound statements. Compound statements that have the same value in all possibilities are said to be equivalent. The equivalent notation in mathematics logic is like this. The forms of statements which are mutually equivalent are these. Next, about compound statement negation. Conjunction negation is negation P and Q equivalent with negation P or negation Q. Disjunction negation is negation P or Q equivalent with negation P and negation Q. Next, implication negation is negation P then Q equivalent with P and negation Q. And the last, negation B implication is negation of P if and only if Q equivalent with P and negation Q or Q and negation P. Next, about conversion, inverse, and contraposition. Conversion, inverse, and contraposition are other forms of implication where the conversion of P then Q is Q then P. The inverse of P then Q is negation of P then negation of Q. And the last, the contraposition of P then Q is negation Q then negation of P. Okay, for the last materials is conclusion drawing. Drawing of conclusions is the conclusion of several compound statements that are interrelated. In drawing conclusion consists of several ways, namely A. Modus ponens, B. Modus tollens, C. Syllogism. A. Modus ponens. P then Q is premises 1, P is premises 2, so the conclusion is Q. B. Modus tollens. P then Q is premises 1, negation of Q is premises 2, so the conclusion is negation of P. The last, syllogism. P then Q is premises 1, Q then R is premises 2, so the conclusion is P then R. Okay, those are the important points to remember in studying mathematics logic. Next, we will try to answer the questions. For the first, premise 1 is, if Ari likes to eat chocolate, then Ari is fat. Premise 2 is, Ari likes to eat chocolate. The conclusion of the two premises above is blank blank blank. So the answer is, premise 1 is P then Q. Premise 2 is P. Conclusion is Q because this is modus ponens. So the conclusion is that Ari is fat. Next, the second, premise 1 is, if today is Sunday, then school is off. Premise 2 is school does not off. The conclusion of the two premises above is blank blank blank. So the answer is, premise 1 is P then Q. Premise 2 is negation of Q. Conclusion is negation of P because this is modus tollens. So the conclusion is today is not Sunday. Okay, that's all about mathematics logic. Once again, don't forget to like, comment, and subscribe. Bye-bye!